state space model for the given mechanical system. You know the mathematical model of this. You know the mathematical model of this. What is the mathematical model of this? Write the state equations for a mechanical system. Mass is m, spring constant is k, applied force is f of t, the dashpot constant is b. We know the mathematical model. The displacement is x. Displacement is x. Therefore, the mathematical model is m d square x by dt square plus, here one end is fixed, other end is moving. Therefore, b dx by dt. Here also one end is fixed, other end is moving. Therefore, kx equal to applied force f of t. This is the mathematical model of mechanical system. How to represent this in state space? There is no friction given for these wheels. That's why it's not taken into account. Friction-free wheels. This we are assumed. Therefore, BR here, BR, another name for the B. We have to find the highest degree. We have to keep the highest degree in the left-hand side. In the third order, what we did, we keep the highest. We kept the highest degree in the left-hand side. We other variables to the right-hand side. The same way we have to write like that. So keep the d square x by dt square as one side. D square x by dt square equal to 1 by m f of t minus b dx by dt minus kx. The same way, we are assuming that x equal to x1, the output x equal to x1. x1 dot equal to first derivative of x1 is x2. x2 dot equal to, why we are keeping x1 dot equal to x2? What is the meaning of that? What is first order differential equation? If you write a dy by dt plus by equal to c. Can I write like that? C u of t. Dy. Keep dy by dt one side. Dy by dt one side. What you will get? 1 by a c u of t minus by. What is the derivative? This can be written as y dot equal to 1 by a c u of t minus by. So this can be written as y1 dot equal to y1. So it is a first order equation. It is a first order equation. Simple first order equation is x1 dot equal to x2 is a first order differential equation. Another differential equation I am writing, x2 dot equal to x3. Whether I have to write? No, because x2 dot already we know. We will replace this x by x1, kx1 minus. This is dx by dt is x1 dot, bx1 dot, f of t multiplied by 1 by m. This can also be written as f of t divided by m minus b by m. x1 dot equal to what? x2 minus kx1. Now we can write in state space model the x2 dot equal to minus b by m x2 minus kx1 plus f of t divided by m. K by m. That's all we got in state space model. What is the state space model in matrix form? The second order. That's why x1 dot, x2 dot equal to, what are the two variables? x1, x2 plus what is the input? U of t. F of t. Here, what is the first equation? Only x2 is there. 0, 1. Second equation, x1, x2 both are there. minus K by M minus B by M. Here, this f of t is in second equation only, not in the first equation. A matrix is, in this case, this is A matrix, this is B matrix. We wrote in state space model. So in the examination, they may ask, they will give the mathematical model. You have to find as we did in first unit, but we have to convert this into state space model. We have to convert this into state space model. This is the simplest sum